My guest today is Dr. Robert Ian Holmes.
I suppose I was sort of self-employed most of my life, traveled the world, went to many countries, about 18 different countries. And finally settled here in Australia, where I'm quite happy. And first attended university when I was 50, probably a bit old, but anyway. I did a degree in astronomy first, which I enjoyed. Always been interested in astronomy and space type things. I followed the moon landings very closely when I was a teenager, and even before that, Gemini and so on. I really thought we'd be on Mars by long before the year 2000, but of course it hasn't happened yet. But maybe soon, I don't know, with Musk and so on. He's got some really great and very technical rockets going. Yeah, after that, I did a degree in mining engineering, and then a master's in environmental engineering, and then finally a PhD in climate science/mitigation. So, yeah, that sort of brings us more or less up to date. I've been running the YouTube channel for since 2012, I think. And I've been on X since probably about 5 or 6 years now. Twitter, yeah.
All right. Let's talk about your book that it came out not long ago, right? 442 pages, Climate Truths.
I've been working on it since 2016, really. And sort of got it finished now. In order to finish it, I had a few health problems after COVID, and to get it finished, I enlisted a co-author, Brendan Godwin, and he's been quite good. It added some new material to the book and helped me to finish it while I was recovering with my long COVID or whatever I had. We completely agreed on the material in the book. And so it's the same inside, but we didn't agree on the cover. So we've got two covers to choose from. We got this one, which is my design, and this one, which is Brendan's design, but it's the same inside.
Okay. And I don't know, do you want to give us a high-level overview of what the biggest takeaways of the book might be?
I guess what we show there is that our CO2 emissions are not a problem. They're not going to cause either any measurable global warming or certainly no climate changes. And it's quite impossible, really, for this tiny amount of CO2 increase, which is minuscule, to do really anything, because we also show that there's no what they call a greenhouse effect or an enhanced greenhouse effect. There is a presence of atmosphere warming, which is associated with every planet or planetary body that has an atmosphere, a fairly thick atmosphere like we have. But it's not related to greenhouse gases or a greenhouse effect.
All right. One thing, I've been tweeting out quite a few of the figures and excerpts from your book, and one that stuck out was talking about the temperature on Venus. I'm going to read a little bit here. It is quite easy to calculate that if the Grand Canyon was 28.7 miles deeper, then temperatures of the order of the Venusian surface, temperatures on Venus, will be found right here on Earth. And this does not include any input from geothermal heat. So do you want to talk about that a bit?
Sure, that's correct. A lot of people, a lot of scientists for, I don't know, the last 40 or 50 years have been saying that Venus is hot because of a greenhouse effect, because there's 96.5% CO2, or greenhouse gases, they call them, in the Venusian atmosphere, whereas compared to Earth, which is only about 2.7% greenhouse gases, which is water vapor and CO2 and some other minor gases. I realized that they were quite wrong here, because there can only be one cause of a surface warming on a planet like Earth or Venus, there can't be two causes. And the cause is not a greenhouse effect, it's sort of compression coupled with insulation and convection. So those three factors combined cause a thermal gradient in the troposphere of Earth or Venus, and that leads to a surface thermal enhancement. So the warming that Earth's surface has over what it's supposed to have from black body theory comes directly from that and not from a greenhouse effect. The Earth really cannot warm itself by its own emissions, which is what they're claiming. They're claiming that the Earth can warm itself by its own radiative emissions. I mean, that's just illogical and impossible.
On page 98, you say, if a greenhouse effect is the cause of the lapse rate, then there would be no lapse rate underground. That's a major point, isn't it, of yours?
Yes, that's right. The greenhouse effect people say that where the greenhouse comes from is the short-wave radiation from the sun hitting the surface of the Earth and turning into long-wave radiation, which is then emitted, and then some of it is reflected back to Earth by so-called greenhouse gases in the atmosphere. That's their theory, but of course the lapse rate, which is caused by autocompression, convection and insulation, continues even below ground, continues underground. I used to work in mining, and I was a ventilation specialist, and I had to account for the warming from autocompression in order to make sure there was enough ventilation to cool the miners underground. So it wasn't just heating from the surrounding rock that I had to worry about. It was also this lapse rate, or if you like, autocompression, which is what it's called in mining. Meteorologists call it a lapse rate. It's a very similar lapse rate on Venus, but the difference is with Venus, the troposphere is very thick because the atmosphere is thick. So instead of being like 5 or 10 kilometers like the troposphere on Earth, on Venus it's 50 or more kilometers. So you've got all that depth of atmosphere, if you like, all that kilometers of lapse rate added together, and that's what makes the surface thermal enhancement, why it's so hot on Venus.
So I see that you referenced the work of Nikolov and Zeller. Would you say you pretty much agree with them, or do you have points of disagreement or major ones with them?
I don't know their work in detail. I have glanced at some of their papers, but what they seem to be saying is basically something similar to what my papers show, that the surface thermal enhancement and the gradient is not caused by greenhouse gases or a greenhouse effect.
All right. And now I'm looking at page 49, which I think might be one of the key pages of the whole book about likely features of the real causes of climate change. You have about climate change. You have about 6 bullet points there. You want to talk about those at all? Because it's very complicated, right? With all the cycles, 16 cycles possibly.
Yeah, sure. I identified years ago from the literature about 16 different climate cycles now that influence our climate and cause climate changes. The problem with the IPCC's scientific reports is that they acknowledge just one climate cycle, which is the 11-year solar Schwab cycle. It sort of goes up and down a little bit over 11-year cycle and doesn't really do anything, makes a 0.1 degree of warming, a 0.1 degree of cooling, and it doesn't do anything. So they just talk about that. But of course, there's, as I said, there's 15 other climate cycles that they've totally ignored, and they're not in any IPCC report. But more importantly, they're not in any computer models either. So the models that they're using to model future climate states are not going to be correct because they don't include these climate cycles that are well known and they're in all the literature. The most important ones for us at the moment, when we're talking in human timescale, in human years, human lifetimes, let's say over the last 100, 200 years, would be the 60-year Yoshimura climate cycle, probably 61 years it is. It peaked, it got warmer in 1880, and 1910 was the cooler part of the Yoshimura. Then it warmed again to about 1942, is another peak, and then it cooled again to 1975 or so, and it's warmed up again to where we are now. So this is the Yoshimura climate cycle. It's very prominent in a lot of proxy data, and it's the cause really of most of the 1975 to the present warming. And then there's the 220-year Schwab cycle, which is sort of peaking at the moment as well. So that's adding. So all these climate cycles piggyback on each other, and they add to each other. And there's two longer-term climate cycles that are underpinning the Yoshimura and the Swiss cycle. That's the 1,000-year Bond cycle and the 2,300-year Bray cycle. So you can see these graphs in my book. Also, I have them on my YouTube videos. One of my YouTube videos has them as well. So climate cycles have caused climate changes throughout the Earth's history, and they still do. It's no different today. CO2 has had no measurable effect on the climate. The changes in CO2 levels are a result of warming and cooling on Earth. Earth's warming and cooling cause CO2 changes, not the reverse. So CO2 changes basically have no effect.
All right. I see that you included this prediction from a Russian astrophysicist about 1.2 C of cooling by 2100. How predictable do you think that is? Do you think we understand it well enough to make that prediction now, or what do you think?
No, I don't think so. That's Absamatimov. I can never pronounce his name.
Right, I didn't even try.
Yeah. But anyway, I mean, there's a lot of people who have different ideas. He's one of them. I mean, I don't necessarily agree with it, but he's a prominent scientist in Russia. I mean, you can't really ignore his work, but you have to look at it like you have to look at all scientific works. And but predicting the future, as you know, is quite difficult. Future climate states are very difficult to predict. And definitely you're not going to do it with a computer model that's driven by CO2, because CO2 doesn't drive climate. So you're wasting your money on that.
One thing you mentioned on page 90 is that people think maybe that the sun doesn't produce a long wave radiation, but it produces 2 million times as much as Earth does. So
yes, it does. It's strange, but you see a lot of figures that show the IPCC present these figures. They show the sun having a lot of shortwave radiation, all shortwave radiation really, and then they show the Earth over here with a little bit of longwave radiation. But it's not like that at all. The sun emits electromagnetic radiation at all wavelengths, including longwave, and a lot more than Earth does actually. The sun peaks at about 6 million times the Earth's peak emissions, and the sun emits about 2 million times as much longwave radiation in the bandwidth that CO2 sort of captures. 11 to 13 microns, I think, is the main capture area for CO2 molecules. Of course, the Earth only takes a small amount of the solar radiation that comes from the sun, about 1/2 billionth of it. That's what the Earth intercepts at its distance from the sun. So you have to divide 2 million by 2 billion to get the amount of long-wave radiation that actually reaches Earth. It's less than 1 watt per square meter when it gets to Earth, but still that is enough to cause the CO2 to react and other greenhouse gases. So these gases, these so-called greenhouse gases, are being thermalized not only from Earth's IR emissions, but from solar IR emissions as well. So when they're being thermalized from above and as well as from below, then you haven't got a blanket. You haven't got a greenhouse blanket to warm the Earth. Imagine if you're, I can explain it probably better this way. If you're laying in bed and your body's emitting heat, so it's a cold night, say, your body's emitting heat, how would you warm yourself? You'd cover yourself with a blanket. That would keep you warm because the blanket would stop really convection. It would stop heat loss from your body to the atmosphere around you. That's what they say is happening to Earth. They say, the greenhouse people say, that the Earth is the source of all long-wave emissions. Therefore, putting a blanket on you, the CO2, will stop you from losing heat. But that won't work if the blanket is, if the heat is coming from outside the blanket as well as from inside, as well as from you. If the heat was coming from outside the blanket, then the blanket's not going to work. Simple as that. So as I say, if the greenhouse gases are thermalized from above as well as from below, which they are, then a greenhouse effect can't work.
All right. And then you make a point about the heating of the oceans is probably a lot more important than what's going on in the atmosphere, and that the sun's shortwave radiation, it penetrates deep in there and that can heat the ocean. But long-wave radiation does not penetrate and does not heat the ocean much, right? Just the surface.
That's correct. That's been measured. Now, the oceans are heated by shortwave radiation from the sun, which can penetrate down into the ocean hundreds of meters. But the long-wave radiation coming, whether it's coming from the sun directly or whether it's coming from the atmosphere, so from greenhouse gases, cannot heat the oceans because it only just touches the surface. It can only penetrate about 10 microns. So it just touches the surface of the oceans, and instead of causing warming, it would probably cause cooling because it would evaporate the surface layer from the ocean. So back, in other words, back radiation from CO2 cannot possibly heat the oceans. It's too weak. Only strong shortwave solar radiation direct from the sun can heat the oceans.
And do you think then that variations in clouds are a huge factor here because that changes how much shortwave radiation is heating the ocean?
Yes, I hear it all the time that over the last 50 years, they claim the solar radiation's gone down. It's been measured from space. It's gone down slightly. The sun's getting a bit cooler, therefore, but the troposphere down on the surface, we're getting warmer. So therefore, they say it can't be the sun that's warming us. But that's not true. They say it's a fingerprint of greenhouse warming, that the stratosphere is cooling, but the troposphere is warming. They claim that is a fingerprint of greenhouse warming. It can only be caused by greenhouse gases. That's what they claim is. But what if the sun is cooling a little? It can still warm the troposphere and cool the stratosphere. The stratosphere will cool if the sun is cooling because of incident solar radiation. But if there's less cloud cover at the surface, low cloud cover, especially tropical low cloud cover, then you're going to get more solar radiation hitting the oceans and heating them up, which will cause global warming. So there's graphs on that in my book and an explanation of it. For every 1% fall in lower tropical cloud cover, that will cause global warming of 0.06 degrees centigrade. That's been measured. And we know that in the period sort of 1975 to 2000, in that approximate period, lower tropical cloud cover has been measured to have fallen by 6%. So 6 times 0.06 degrees is 0.36 degrees centigrade. So that would cause that alone would cause 0.36 degrees centigrade of global warming in that approximate period. So yes, the Earth can warm at surface when the sun is cooling. It's just that if you have less cloud cover, that will cause warming at the surface.
And then it sounds like you do agree basically with Shaviv and Svensmark about the cosmic ray theory that changes in the sun can change the cosmic rays and then change the cloudiness.
Yes, a lot of these climate cycles that are in the literature that are referred to depend on cloud changes. So a lot of climate cycles are caused by changes in cloud cover. Clouds are very powerful forces when it comes to climate change. They cause a lot of climate changes. But the sun itself puts out cosmic rays, but only low energy cosmic rays. The higher energy cosmic rays, that is the ones that penetrate right down to the bottom of the atmosphere and cause a muon shower in the lower troposphere and cloud formation. Those powerful cosmic rays come from outside the solar system, and they're caused by things such as starbursts, generally close by starbursts in the Milky Way, or they can be caused by a lot of density. So if the solar system passes through a dense region of the Milky Way, for example, a spiral lamb, that would cause cloud cover changes and climate changes. The solar system, the sun and all the planets go around the Milky Way once every 250 million years. And during that time, they pass through the spiral arms of the Milky Way. There's 4 spiral arms in the Milky Way. At the moment, we're going through a spiral arm segment called the Orion spiral arm segment. And we're in that, and that's why we're in the current period of ice age. We're in an ice age at the moment. We have been for about 30 million years or so. It was initially started by nearby starbursts. That's all detailed in the book. But the CO2 proponents still go on about CO2 changes as if they had some real serious effect on these massive long-term climate cycles. There's another climate cycle, not as long as the 135 million year climate cycle I was talking about there, which is going through the solar system, going through spiral arms, as well as the solar system going around. The orbiting the Milky Way also goes up and down through the disk of the Milky Way, a bit like a dolphin up and down, and that causes a 33 million year climate cycle, which is the second longest cycle that I found in the literature. So there's 132 million year climate cycle is the longest climate cycle, and the 33 million year climate cycle is related to us going up and down through the disk of the Milky Way. So it's due to density changes and changes in cosmic ray flux arriving on Earth. And as you said, the sun does affect cosmic rays, but it only really affects low energy cosmic rays. Higher energy ones get through.
Okay, I want to read a couple more interesting excerpts here. Changes on Mars. Mars has also seen recent climate change with the accelerated melting of the southern polar ice cap in the years 1998 through 2006. Then you say, as already noted, the second half of the 20th century had the highest solar activity in at least 4,000 years and possibly up to 11,000 years. Any comments on that?
Yeah, that's correct. It looks like we're at a grand solar maximum right now. I don't mean today. I mean over the last few hundred years, because we're talking about very long cycles of the sun now. We're at solar maximum, the highest sort of solar emissions that we've had for 11,000 years. This is a paper in the journal Nature. So if the alarmists usually complain about what journal you publish in, and rather than looking at the material you've published, they always complain about the journal. Well, they can't complain about the Nature journal, which is their favorite journal. So anyway, that's where this material is published, about the 11,000 year solar maximum we're in at the moment. The solar activity has been going down since about 1970s or 80s. That's true, but it's only marginal. We're still at solar maximum, really.
And then you write, one very interesting feature of clouds is that all clouds over both the Antarctic and over Greenland provide warming. This is because even though the clouds are fairly white, they are not as white as those surfaces there.
Yes, warming of the Earth has a bit to do with albedo, which is how much is reflected and how much is absorbed, and that depends on the whiteness of the surface. If you've got a forest, it's going to absorb more energy than a white surface like, I don't know, Antarctica, Greenland, or the surface of clouds. So how much of the Earth is a white surface? That will affect how warm the Earth is, because it'll affect the albedo. Yeah, I do go into Antarctica a little bit. I've got a YouTube video up specifically on Antarctica, whereas the NASA scientists think it's a bit of a mystery that the Antarctic hasn't warmed in the last 50 or 60 years like they think it should have warmed, but it hasn't warmed at all. It's just been stable, same temperature. They think it's a mystery, but really it's not a mystery. The prediction of the CO2 theory, if I can call it a theory, it's not, it's just a hypothesis which has been invalidated. But anyway, the CO2 hypothesis is that when there's more CO2 in the atmosphere, what will happen is that both poles must warm, and above the tropics, about 10 kilometers high up in the upper troposphere, that should warm too. There should be a hot spot, a warm spot. Now, only one of those three things have actually ever been detected. There is warming in the Arctic, but there's no warming in the Antarctic, and there's no hot spot over the tropics either. So sort of 1 out of 3 is not really confirming the hypothesis.
And even the warming in the Arctic, you show that as being cyclical, right? It's not monotonic.
The warming in the Arctic is also not caused by CO2 levels changes either. That's again a cycle. The Arctic was just as warm in the 1920s and 30s as it is right now. So again, this is the Yoshimura climate cycle. That's clear from the data, the Hadkrut Arctic data. Anyone can have a look at it and check it and see if I'm correct.
So recently, going back to, I don't know, last 100+ years, Antarctic temperatures have been cooling, or they haven't been very cyclical. They haven't varied nearly as much as the Arctic. Do you have any predictions over the next 100 years? Are they going to flip and the Antarctic might warm a little more, or what do you think?
There is what I would call a polar seesaw. That is when the Arctic warms, the Antarctic cools, and vice versa. When the Antarctic warms, the Arctic cools. It's a well-known in the literature. It's called the polar seesaw, and the fulcrum of this seesaw is not on the equator where you might think. It's about 60 degrees south of the equator. So it's quite far south. Why it is so, I'm not sure anyone really knows, but it's definitely been measured.
Do you have thoughts on what happened with the Hunga Tonga eruption and how that affected temperatures?
I haven't really been following that, Tom. So, like all eruptions, it does cause a temporary change in aerosols in the upper atmosphere, especially if it's a strong eruption. So it's just a temporary change.
It does look like the satellite data showed a spike, and then in the last 15 months, it's been cooling the other way. Do you think that's meaningful climate-wise, or this is just natural variation, and we're not really learning anything new from it?
I don't think we're going to. It's something similar to Pinatubo, which caused a temporary change, and I don't think it's really any type of long-term thing. Yeah.
I am seeing some discussion on X about comparing the warmth of 1878 to the warmth of 2024. That here in Minnesota, 1878 was a year without a winter. It was just a very, very warm year. Do you have any thoughts on that one?
Yes, 1880 was a peak in the Yoshimura and a couple of other climate cycles underpinning it. What's happened actually with the data, the temperature data record, is that the alarmists who are pushing the greenhouse effect, the CO2 effect, they've cut off the data at about 1910. So that's what they did in Australia. I'm not sure about the US, probably the same, but they start the data from 1910, whereas our record goes back to the 1860s, but they don't include that because it was quite warm. It was as warm as it is now, probably even warmer in the 1880s. That was when Australia had the worst bushfires in history in the 1880s. They were so severe in Victoria here that there was ash falling on New Zealand. That was recorded. So it's just inconvenient, so they cut it off. They just said, oh, we'll start the record at 1910. That was a cool period. Again, the Yoshimura cool period. And from 1910 to 1940, that was a warming. And 1940 to 1975 was a cooling, and 1975 to now a warming, as you know. So what they've tried to do with the data is they've changed pretty well all the major data sets to better align with the CO2 record in their models. So they've smoothed the whole record. They've smoothed it, got rid of all natural variability, all the peaks and troughs, they've got rid of them. Deleted everything before 1910 because it was too warm. They didn't like that. And they got rid of the 1940 warming as well. And they just made a nice, smooth, continuous nice record going up to the present to match the CO2 rise. I mean, it's just so obvious, it's ridiculous. But the problem is these changes have only been recorded since 2008. So what they did before that, who knows? But definitely they were doing it before as well, especially at GIS and places like that. So yeah, the most tampered with data set is GIS, the New York guys.
Yeah.
Hansen and I better not mention some names, but you know who they are.
Yeah, so you mentioned that the temperature that data has been tampered to match the CO2, but then the CO2 data is also tampered with, right? You talk about that?
Yeah, it is. Yes. The biggest problem is the CMIP5 models that they're all using, 6 models that they've gone to now, the climate models. I mean, even they say they're not predictive. They're just trying to project future temperature states and future climate states. They're not trying to predict anything, so they say. And all their predictions or projections, whatever they are, have been totally wrong. When in hindsight, when you look at their projections and then you look at the measurements are far below their projections. Usually about half or a third the height of the projections. This is because they're driving their models with CO2 instead of using natural climate cycles, which is what they should be using. If they use natural climate cycles, though, then CO2 wouldn't have a role to play. So it would be out of the picture, which is what they don't want, obviously. So it's more of a religion than a science. That's what it is. That's what we've got. The problem is they are now changing our energy system based on these fake models, and it's costing a lot of money. It's costing, well, the average person, it's costing them. The average Australian is now paying about $1,500 a year for these climate related things, and probably it's the same in America. And altogether, when you count it up worldwide, it's amounting to trillions of dollars. And of course, 75% of emitters are now not even controlling their CO2. For example, China, India, Russia, USA, Brazil, all the BRICS countries, which is about 75% of all human emissions. They're not controlling their CO2 emissions at all, not even trying to. So the rest of us that are trying to control our CO2 emissions, even if they're right about CO2 being a greenhouse gas, etc., we're wasting our time because there's only Europe, UK, Australia, maybe Canada, I don't know, maybe New Zealand. That's about all. Which is only about 25% of global human emissions that we're even trying to control. So even if they're right, we're totally wasting our time.
Do you think that there's any move afoot to put temperature stations in areas on purpose that are affected by urban heat island or affected by car engines, anything like that? Do you suspect that?
Yeah, I think that's what they've been doing. They've actually been caught when there's been a station affected by urban heat island and one in the countryside nearby that's unaffected. They've been known to adjust the country one to match the city one, the urban heat island one, which is, of course, the exact opposite of what they should be doing. So they've even been extending urban heat island affected thermometers hundreds of miles out into the countryside, and saying, "Oh, all that is now warming." So there's a lot of problems with this, with the data collection, with the sighting of the thermometers. And then, of course, there's the adjustments to the data. They even adjust past data from 100 years ago to make it cooler. And of course, they adjust present data to make it warmer. So the rise is steeper. So whatever adjustment they make, it's always to make the temperature record rising more and more in line with the CO2 record. That's what they've been doing. It's not science. I don't know what it is, but it's not science, what they're doing.
I've heard quite a bit about outsiders like Anthony Watts looking carefully at temperature data for the UHI in the U.S. People are looking in the U.K. as well. How about in Australia? Is someone auditing those stations to see how high quality are they?
Yeah, there's Dr. Marahasi. She has been looking into it. It's she's probably the most prominent one that's checking the meteorological data. There have been a lot of changes made that shouldn't have been to data at various stations in Australia, and also the overall record has been changed when it shouldn't have been, in a way that it shouldn't have been, I should say. So it's unfortunate, but that is what we've got. We've got people who, I don't know, are not exactly being scientific, or they're so convinced that the world is ending because of this CO2 problem that they think the end justifies the means, and they're just changing things to force action. That's what they're doing. It's unfortunate, but that's what is definitely happening.
Have you looked much into the sea ice data to see if that's been tampered with? I don't know the answer to that. I don't know why it wouldn't be.
I don't really know what they've done there. It's supposed to be all satellite measurements now, so it shouldn't really be a problem. Of course, the predictions were that the Arctic was going to be ice-free by 2020 or something, and that really hasn't come to pass. We had a minimum in 2012, but that was a cyclic minimum, and the area of ice in the Arctic has grown considerably since then. So it just seems like a natural change. I mean, there could be some problem with the Arctic in terms of ice because of anthropogenic effects such as black carbon. That's possible, but that's nothing to do with CO2. I mean, the Chinese are building so many thousand coal-fired power stations. They're putting out a lot of black carbon. Wouldn't surprise me if that was causing a certain amount of ice melting due to albedo effects on the Arctic. And that could be a reason why that black carbon's not affecting the Antarctic, because it doesn't really get down that far south. So it could be affecting the Arctic ice in that way. But that is not CO2.
I'm seeing claims about Arctic sea ice volume. Is that something you think we can measure somehow with satellites? Not just the surface area, but the volume of the ice up there?
Well, there are supposedly satellites that can measure the depth of ice. They can tell whether it's 1 meter or 2 meters thick. I'm not quite so sure about that myself. I'm highly skeptical of that, and also of there is a satellite that supposedly measures how much ice is melting on Greenland and the Antarctic as well, due to the Earth's wobble. I think that's a bit dubious as well, really, that they could do that.
I don't know if I've asked you about this before, but how confident are you in measurements of ancient CO2 levels based on a bubble in the ice that's supposed to be 700,000 years old? Do you think we can measure CO2 there and figure something out about what happened that long ago?
No. The claim has always been that, oh, CO2 is higher now than it's been for 800,000 years. That's what they always say. And when we ask how you know that, they say, oh, well, the CO2 ice record from Vostok Station, the ice up to, from now back to 800,000 years, it doesn't show CO2 in the ice going over 300 parts per million. Well, I think that the ice core record is probably wrong. This is because of the Knudsen diffusion effect, that when you get a certain amount of pressure on the ice, as it builds up, you get more and more snow on top, and the ice gets crushed. And what happens is the small air globules that are inside the fern in the snow and then in the ice, they diffuse out through the ice. And so when you drill that ice out 800,000 years later and check the amount of CO2 in an ice bubble, it's not going to be representative of the paleoatmosphere. I think a more accurate measure of CO2, if you're talking about proxies, is to use plant stomata. Plant stomata data shows a much greater variability in CO2, in paleo CO2, and also shows a higher level of paleo CO2. So as well as having sort of a greater range of about 20 times greater range in CO2 levels, it shows a higher level of CO2 as well in the proxy data. So I think the plant stomata data is more accurate than the ice core record. But of course, the IPCC only use the ice core record. They won't touch the plant stomata CO2 record.
So excluding the last maybe 150 years, what do you think was the highest CO2 level out of the last 800K years?
Well, the plant stomata record quite regularly goes over 400 parts per million, even relatively recently. So in the last 1,500 years, it was about 450 parts per million. Around about 400 or 500 AD, there is a PhD thesis by, I forget his name, but he recorded plant stomata data over the last 2,000 years, and it went to about 450 parts per million, around about 500 AD. So even in the last couple of thousand years, we could well have seen CO2 higher than it is now.
You have any thoughts on what the CO2 level would be right now if humans never existed?
It'd be the same. It'd be the same as it is now. I really don't think we've got very much influence over CO2 levels in the atmosphere. I don't think we increase them very much, and I don't think we could reduce them very much if we even tried to. So I think it's the CO2 level in the atmosphere is set by nature. It's set by Henry's law. And really the oceans, the temperature of the oceans determine the level of CO2 in the atmosphere. And so our efforts to reduce the level of CO2 in the atmosphere are probably going to fail.
So there is some argument that we can look at the isotopes of carbon in the atmosphere and figure out that fossil fuels put that CO2 up there. But you think that varies naturally too, right? The isotopes, the levels of different carbon isotopes, that also varies naturally, not caused by us?
Yeah, I've heard this argument. I think really the best person in this field, in this area, would be I'll just forget his name now. Oh yeah, Professor Salby. He would be the best guy. He's recently deceased, but his work showed that the CO2 levels were really natural, and anthropogenic effects did not change the natural level of CO2 very much at all. So his work is exactly in this area. Oh, used to be, yeah.
One other quote I enjoyed from your book is this: the IPCC are a political organization, and the vast majority of scientists in the world dissent from the IPCC.
Mm.
So let's see. I guess
Yes.
you include the Oregon petition in there. That's one strongly worded petition where people disagree with the IPCC.
Well, the IPCC always claim we've got 2,500 scientists, and they're not all wrong, and they compiled our scientific reports and so on and so on. But really, what matters in this area is attribution. And the vast majority of those 2,000 or whatever it's claimed scientists are not working on attribution. There's only about a dozen of them out of the 2,000 that are actually working on what causes what. Now, we have to remember that there's been thousands, tens of thousands of papers published over the last 40 years or so in the field of climate change. And yet not one of them has measured a warming in the troposphere and attributed any part of that warming to rising CO2 levels. That's never happened. There's no paper like that. Why there's no paper like that, I don't know, but the science is not there to claim that CO2 is causing the current period of global warming. Otherwise, there would be at least one paper that has measured it, and no paper has measured it. So it's down to attribution. As far as Working Group 1 in the IPCC, they work on the science of what they call the science of climate change. There's a few hundred scientists in that area in Working Group 1, but only even in that group, there's only a small number of them who are working on attribution. About a dozen, and a lot of that dozen are students. Because of the political nature of the IPCC, they were appointed to those positions from third world countries, which is fine, but they haven't got the experience and they haven't even got their PhD yet. So I'm not sure that they really could be listened to in this area.
So, by the way, when you got your climate science degree, was it all alarmism all the time? Was there much talk about natural variability or any of the other things in your book?
In my thesis, in my PhD thesis, you mean? In my thesis, at least 70% of it was on the subject of climate change. Directly on the subject of climate change and global warming. And I was highly critical in it of the IPCC, and my book is basically, a lot of it is lifted straight from my PhD thesis, actually. A lot of the illustrations are from there, and a fair bit of the material too is from a PhD thesis.
Were the professors, though, were they pushing alarmism on you, and how receptive were they to your thesis?
At the university, yes, but well, after I finished my thesis and it passed, it went outside the university to get peer reviewed by several people, and so after it passed, the university put me on in a lecturing position. And then I published a paper on, I think it was my 2019 paper I published on saying that there is no greenhouse effect. I also gave a talk at the university showing that there is no greenhouse effect. Pretty soon after that, I lost my job as a lecturer. I'm not worried about it, but I'm not alone there. Quite a few, even professors, have been fired from their positions when they said something against the so-called consensus. So I've got a long list of them, actually. Quite a few in Australia have lost their positions by publishing or saying the wrong thing in this area.
I just recently saw a claim again that climate scientists have a huge incentive to prove everybody else wrong because then they can win a Nobel Prize. And that's what climate scientists are trying to do. They're trying to prove the null hypothesis or the CO2 hypothesis wrong. But that's not any of the reality that you've seen, right? You get punished for pushing back against the narrative, don't you?
That's right, yeah. Well, universities struggle to get funding. I'll put it that way, as you probably realize. And they do get a lot of funding from governments to research climate change, man-made climate change. There's no money to research that man-made climate change is wrong. There's only money to research man-made climate change is right. And to research into things such as carbon capture and storage, and to produce better solar panels or better windmills. That's where the money is. So this is why the universities have an incentive to follow the so-called consensus and to sort of cast doubt on anything that is different or what they see as controversial.
So I'm doing a thread here about the collapse of the climate scam in the U.S. It is imploding with the second Trump administration. Do you think that has any effect on what's going on politically in this area in Australia, or it's not?
It has had some effect here, although we do have a left-wing government in Australia, similar to the one they have in Canada and the UK. I mean, it hasn't affected government policy, but it has affected some of the universities here because they've lost their US funding. They were getting some funding from the US to do research in this area into man-made climate change. But unfortunately, it's the climate scam is not imploding here, at least not yet. The government's going fast ahead with net zero, spending billions of dollars on it and putting windmills up everywhere, windmills that are made in China using coal, our coal that they buy from us. It's unreal. You couldn't really explain it. It sounds a bit crazy, but yeah, China's making a lot of money, making solar panels and windmills for us and for Europe and for the UK and Canada and Australia, but they're not cutting their emissions at all. Not even thinking about it.
Do you have any sense as from where in the U.S. budget that money would come to go to Australia to fund warmism in Australian universities? It's not connected to USAID, or what is it?
I'm not sure really what area it was coming from, but anyway, it's been cut off, which is a good thing, I think, because we might get some actual real science done sooner or later.
Speaking of real science, I have one more question here. I'm just going to read you about one sentence here about the winter gatekeeper hypothesis. It says here on Grok, the winter gatekeeper hypothesis proposed by Javier Venos and Andy May suggests that solar variability significantly influences Earth's climate by modulating north-south heat transport, particularly during the northern hemisphere winter. Do you have thoughts on that whole theory as the heat transporting and to the Arctic and being lost?
Yeah, what a surprise, that the sun might influence our climate, you know. It's a million times bigger than Earth. Yeah, it could have something to do with it. I've spoken to CO2 alarmists, even to Grok. I had an argument with Grok, discussion. And I was saying to Grok the other day that Grok said that warming from CO2 has been detected. And he cited to me a paper, but the paper actually had found a forcing, not a warming. So I said to Grok, a forcing is not a warming. Oh, okay. And if you're talking about a forcing of 0.01 watts per square meter every 6 months, you have to compare that, the supposed detected warming from CO2 of 0.01 watts per square meter every 6 months. You have to compare that to a natural, just one natural change over the same time period, which is 92 watts per square meter, which is due to eccentricity. The distance of the Earth from the Sun varies. And so over a 6-month period, the top of atmosphere insolation from the Sun varies naturally by 92 watts per square meter, which is so many thousand times more than the CO2 alleged forcing change. And the 92 watts per square meter that we know changes between June and January every year doesn't change the Earth's temperature, because the Earth compensates for it in cloud changes between the northern and southern hemisphere. So if the Earth can compensate for 92, basically if the Earth can compensate for 92 watts per square meter over 6 months like it does, and have no change in surface temperature, how is 0.1 watt per square meter over the same time period going to change the Earth's temperature by anything? It's a natural feedback. It's a negative feedback. So you're going to get a negative feedback. The Earth is going to say, oh no, even 92 watts per square meter is not going to change the temperature of Earth, so why would 0.1 watt per square meter change the temperature there? It just doesn't make any sense.
It does not make sense. All right, we're coming up to the end of our hour here. Do you have other points you want to make before we finish here?
One point I made in the book was about Arrhenius, they always, these CO2 people go back to Arrhenius in the 19th century. I mean, if I quote a paper from 2002, they say it's an old paper. Why are you quoting that old paper? And they're quoting Arrhenius from 1896. It's so strange. But anyway, but even back in the 19th century, Arrhenius lost out to Maxwell. James Maxwell published a book around about 1860. It was before Arrhenius. And he explained what causes the surface temperature of the Earth. And he was quite correct. And then Arrhenius came up with this CO2 stuff. So although CO2 does capture gases in a laboratory and in a glass bowl, I mean, the atmosphere is not a glass bowl. It's an open space, so it's not going to work the same. I mean, when a gas warms up in our atmosphere, the atmosphere is going to expand and cool again straight away, instantly. So it's really it's only the forces of, you know, natural natural gas laws and the sun. Those things are what's going to cause a temperature on Earth and any changes to it, and not CO2 really. So yeah, Arrhenius was sort of disproved wrong even as early as 1909. You see my book, I cited a paper there, I forget which one, but even as early as that, he was shown his greenhouse effect was shown to be wrong, and yet people still bring it up today, and millions believe in it. It's amazing. Yeah.
All right. I think I will let you go, but I am extremely impressed by your book. I've spent a lot of time reading it, going over it with a yellow highlighter. And do you think it was many thousands of hours of work over the course of most of a decade? It looks like it was.
Oh yeah, definitely. Yeah, it was a lot of work. It was a lot of work. Well, I'm glad it's out there now. Um, I realised some of the graphs are a bit dark, especially towards the end, and of course they had to be printed in black and white because the cost of colour here is enormous. So I've put the all the graphs from the book. I've put them up online on my YouTube channel, so anyone's quite welcome to view them or download them or whatever they want to do. And quite clear, and most of them are in colour. So.
All right. And then in the show description, I put your X feed and I put your Climate Truths website, and I put a link to this YouTube video you just mentioned that has all the graphs in color there. So people should be all set. So thank you.
Thanks, Tom. Yeah, that's excellent. There it is at last.
With
First edition.
Fantastic. Yeah, with my family, we have an expression called phoning it in. If people are not really working hard on something, they're phoning it in. But this book is not phoned in. Yeah, it's incredible. It's
well, more than 100 illustrations, 500 references to the scientific literature. I think people will enjoy it, and definitely they will learn something new about climate science, even if they've been interested in the subject for years.
that was the case with me. So thanks for your work, and we'll talk to you next time.
Okay, thanks a lot, Tom.